Hello everyone, I'm Joe. Today I'm going to introduce you something about advanced robotics. Firstly, I want to share some of my personal opinions about advanced robotics. It is robots and connected by a lot of components and have several chips. They can do what has been projected by humans. These three features are normal in robots. I remember when I was in high school, there was a robot interesting group, and we create robots like this and this. However, advanced robots are completely different because they include artificial intelligence, sensors, cameras, and so on. So, today's robots can do more for humans. Now, I'm willing to show you a video which is amazing and shocks me. It is an advanced robot made by Honda. I'm sorry, I can't make it full screen because my computer doesn't allow me to do this. By using its face identity system, it can know people, and as introduced by the video, the robot has memory system and can act as a human. Like it asks three different people what they are willing to drink and serves for them. Now, I'm going to tell you how advanced robotics benefit for healthcare industry. Da Vinci surgery system appeared in 2000, and it had served for more than 20,000 surgeries since it was applied. It is a video about Da Vinci surgery system. Let's take a look.
The Da Vinci surgical system is the most advanced platform for minimally invasive surgery available in the world today. The integration of high-resolution 3D vision, wristed instruments, instruments and intuitive motion control enable the Da Vinci surgeon to transcend the limitations of conventional surgical technologies, making new, minimally invasive options possible for complex surgical procedures. Three network components comprise the Da Vinci surgical system: an ergonomic surgeon's console, a patient-side cart with 4 interactive robotic arms, and a high-definition 3D vision system. Seated at the console, the Da Vinci surgeon views a remarkably clear 3D image of the surgical field. The system scales, filters, and translates the movements of the surgeon's hands on the master controllers to 4 interactive robotic arms on the patient cart. The Da Vinci S HD system provides a magnified view that is both three-dimensional and high definition. The result is a phenomenal, immersive experience of surgery. The precisely controlled micro-movements of the Da Vinci instruments are enabled by the computer processors of the system. These dedicated processors perform millions of safety checks over the course of a procedure for enhanced surgical precision and control. Da Vinci EndoWrist instruments are designed with a unique wristed architecture that provides 7 degrees of freedom for a range of motion greater than even the human wrist. This proprietary design enables surgical maneuvers impossible with conventional laparoscopic tools. As the surgeon operates at the console, the Da Vinci system filters out hand tremor and translates his controlling motions to the articulating tips of the EndoWrist instruments. The Da Vinci system also provides motion scaling that enables the surgeon to tailor the ratio of his hand movements to a corresponding micro-movement at the instrument tip. The system requires that every surgical maneuver is under the direct control of the surgeon. Redundant safety checks prevent autonomous movement of the instruments or the robotic arms. The Da Vinci S surgical system adds to the enabling characteristics of the original Da Vinci to streamline surgery for the entire OR team. Da Vinci S provides fast, foolproof setup, including a motorized patient cart for simplified docking, simple click-lock cannulas, rapid instrument exchange, and an intuitive touchscreen interface. Intraoperative communication between the entire OR team is enhanced with the audio-visual components of the system. The internal view of the operative field is visible on the vision cart or optional patient cart monitor. These monitors can also be toggled to display patient-critical information or a tiled display with multiple windows. Proctoring is enhanced with the telestration capability. Notations drawn on the patient cart monitor can be seen by the surgeon as an overlay on the surgical view at the console. The 2-channel endoscopic cameras of Da Vinci S HD enable better 3D visualization of tissue planes and critical anatomy. The result is increased surgeon confidence and an environment that lends itself to greater surgical precision. LEDs that indicate status on each robotic arm, along with the user-friendly design of EndoWrist instruments, make intraoperative instrument exchange simple. Unlike conventional laparoscopic surgery, the robotic arms move around a fixed pivot point to reduce port-side trauma for improved cosmesis and increased overall precision. The future of surgery includes enhanced visualization, superior instrument dexterity, and operative efficiency in a tightly integrated system. The Da Vinci S surgical system moves surgery forward with a new level of technical capability that enables minimally invasive surgery in complex procedures as never before. Da Vinci provides a streamlined surgical experience that benefits the hospital, the surgeon, the OR team, and, most importantly, the patient.
I'm sorry, maybe this video make you uncomfortable. but it is clear. I apologize. And the second, micro-robots. Micro-robots are tiny robots which help doctors to complete highly precise surgeries. Here is a video about how micro-robots work in eyes operations.
Researchers in Switzerland have developed a robot so small it can be injected into the human eye. The robot could deliver drugs and perform eye surgery even without anesthetic. Brad Nelson, professor of robotics and intelligent systems at the ETH Zurich Institute of Technology, says the microbot could lead to some novel treatments.
If we can make it small enough to fit in a 23 gauge needle, it can actually be injected into the eye with just topical anesthetic or even no anesthetic, and it doesn't also require a suture.
The device is basically a magnet controlled by an external electromagnetic field. It's a bit like the magic trick of moving a metal object with a magnet held under the table, but much more sophisticated.
It requires that we very precisely control the fields and the currents through our electromagnets, and being able to do that in a stable, controlled fashion has been a challenge.
The development could see micro-robots used in all kinds of eye treatments, like delivering drugs or reattaching retinas.
Our first applications are in targeted delivery, treating diseases like age-related macular degeneration or retinal vein occlusions, which we try to deliver drugs to specific locations on the retina.
The most common treatment for macular degeneration is regular injections into the eye. The robot could be placed in the eye for months on end, dispensing drugs exactly where they are needed. So far, their experiments have all been done on the eyes of dead animals, but they have plans to move on to living animal trials and then to human trials.
For the third, service robots work in nursing homes, which are beneficial for nurses to better take care of elders. Let's look at this video.
Introducing CareRobot and Casero, service robots on a guest visit to Parkheimberg in Stuttgart. Their mission.
Oops. The video doesn't work well.
A project to help the staff with their work. He's certainly been a great help to us in our day-to-day work, transporting things, taking the laundry to the cellar and carrying crates of mineral water. He's definitely helped us there, because it saves us time. He can do all those things and we can spend more time with the residents. We are talking about Casero. His speciality, transporting things independently. Once the car has loaded the laundry into the container, she simply needs to press a few buttons on the display to send the service robot on his way. He then picks up the laundry and takes it to the cellar for washing. At night, when there's nothing that needs transporting, the service robot turns to his second job, that of night watchman, patrolling the corridors along a fixed route. A built-in camera allows members of staff to follow him on his travels. Should Casero come across anything unusual, he soon raises the alarm. The member of staff is also brought the first aid case.
Also gerade für mich, weil ich auch
He's a big help, especially to me because I also do night watch in Parkheimberg. He enables me to see that, at least in the corridors, everything is okay, which is really useful. And he also brings me the first aid case. He's a big help.
Das ist dann echt okay.
Hallo, ich bin CareRobot 3. In dieser Woche unterstütze ich die Pflegekräfte bei ihrer Arbeit.
A different robot, a different task. CareRobot makes direct contact with the residents in Parkheimberg. He can even recognize faces.
Ja, Sie möchten doch bestimmt etwas trinken. Ja, doch. Ein Schluck Wasser kann doch nicht schaden.
Ja, da hast recht. Heute noch
Prost.
Oh, tolle Leben.
The second guest robot can independently pour up drinks and then hand them out to residents. What's special about him is that he keeps a record of who's had something to drink and how often. Members of staff can examine the record at any time.
Der Druck zu kontrollieren und nachzuschauen.
We're definitely under great pressure to make sure that the residents get enough to drink. That's a big challenge for the staff. And there's something else Care Robot can do.
Ich bin bereit zum Spielen.
Okay.
Erzählen.
Memory is just one of the popular games on offer from Care Robot on his guest visit to Parkheimberg. And to finish, there's another special ability the service robot can show off.
Transportation robots actually are another type of service robots. Transportation robots are like automated carters, which transport materials among divisions in a hospital. This video is an example to introduce how transportation robots work in a hospital.
I have a delivery for you.
For the robot legs are a set of assistant system. This system helps disabled people who have trouble in walking to work as normal people and to work smoothly. There is a video. It's a successful example and states Robotics system is effective and helpful in helping people to work.
Alice used to be the fastest runner in her class, but when she was 17 she suffered a stroke and hasn't walked properly since. Years of physiotherapy have helped, but she's now testing a device with a difference. This is Lopez, not the American superstar, but the
Oops.
powered exoskeleton. It's essentially a rehabilitation machine which can do some or all of the walking for you. What it's done for Petra is remind her how she used to walk.
I got a eureka moment. Because I felt an old feeling from how to walk normal. And a kind of push-up I felt and my knee lifting. It's what I've forgotten and I can't reproduce it by myself. So I had to feel it again.
Try to keep making those nice steps and then you will...
The designers say the machine knows when the patient is doing something wrong.
For instance, some people cannot lift their foot up properly. What this device does, it senses that it is not lifting up the foot appropriately. It compares it with a reference pattern and then exerts a force or a torque to assist that subject in doing it.
So far, we have known some benefits that advanced robots support for the healthcare industry. Now, let's take a look at advanced robots can do for manufacturing industry. It enables manufacturing workers to complete dangerous and highly precise jobs, and it effectively and efficiently increases manufacturing workers' productivity, and it lets manufacturing workers grasp new skills, and it improves manufacturers' performance. Now let's see a video which is amazing about how to make a car.
From a manufacturing standpoint, the way we assemble this car, the way we put it together, all of this is essentially very different from another car. The Model-S process stage it all starts with raw material. We have coils of aluminum, different gauges, different types of aluminum, maybe 50, 60 coils. We start the process by uncoiling the coils in a special machine called blanking machine that allows to flatten the metal first and then cut it into flat pieces. We call them blanks. In addition to traditional blanking tools, we're using laser. And then with these pieces, we feed them to the press lines, these gigantic dies. And the press lines essentially form the panels. Boom. We are getting all of the parts necessary to make the body of the vehicle out of those gigantic machines. And then all of these parts, as they are finished, so to speak, are brought to the body shop.
The role of the body center is to take all the stamping panels that we make and we bring all of that together in one central location. And that's where we actually put the Model S together. We'll start, we do an underbody, which is the main floor system of the car. And then from there, we'll move to body sides. That's the internal reinforcement as well as the outer skin. And inside the framing area, we take the body sides, the underbody, and the front end of the car, and we actually marriage it all together. One of the most unique things about this body center is we actually have 5 different overall joining methods for the body shell. We use adhesive, we use self-piercing rivets, we have cold metal transfer, conventional resistance welding, as well as a new delta spot welding system. When a body leaves the body center, it's actually a full completed body shell ready to be prepped and painted.
We have a gigantic robot that takes the body and put it into a conveyor, and it's conveyed to the paint shop. You have multiple pre-treatment, primer, base coat, clear coat. All of this is supplied with robots that have a special ability to paint in a very clean environment. You get a beautiful painted body that's coming to General Assembly, where we have these super elegant robots we call smart card, where every card is essentially moving through the factory by itself. It follows a magnetic strip, and essentially the card is being assembled from inside out. We're utilizing automation to the fullest. We have a variety of robots, from the teeny little ones to huge ones that are able to move the entire body itself. One of the robots that I'm always very impressed to look at is the one that puts the seats inside the Model S. And the same robot is able to change tools, go from a seat handling device to putting the windshield, actually grab the windshield, put some glue around it, and then put the windshield onto the car, as well as to the rear glass of the vehicle. So talk about versatility here.
We have most everything we need right here in-house. We do the majority of our stamping panels ourselves. We have design engineers here at the facility, so we're very nimble and very quick at what we do.
Currently, it takes about 3 to 5 days for a Model S to go from raw material all the way to being finished on the bamboo line. It's magnificent. It's like a piece of art. We constantly try to improve process efficiency. We want to push the boundaries of what can be done by robots versus humans. So it's a constant evolution. This Tesla factory is the future of the USA and the world. That's the way I see it. We are building the future here. That's how proud I feel about this.
It is amazing. All these robotics machines are like transformers. All this on my presentation. Thanks for pay attention. Bye bye.